Hello everyone. Today we will start exercise 1.1. Till last video, what we have done, we have seen what are the sets, what's the definition of sets, then finite and infinite set, right? Now we will do exercise 1.1. Okay. Now here, list the elements of the following sets. We have to write the elements. Okay. So now, list the element means what you have to do, basically you have to write in roster form, because there only we write all the elements. Now, x is an integer and x square equals to 9. Now, which integer, if we square, will get 9? 3 and minus 3. Okay. So, as x square equals to 9, what you can write? X equals to root 9, which is plus minus 3. Because if you will do square of plus 3, you will get 9. If you do square of minus 3, then also you will get 9. So here the answer will be 3, negative 3 and positive 3. Okay. Now next, x is a positive integer less than 5. It should be a positive integer. Positive integer starts from 1 or 0. 1. Yes, correct. 0 is neither negative nor positive. So it starts from 1 and we have to write less than 5. So 1, 2, 3 and 4. Now next, x is an even natural number divisible by 5. If I write the number which are divisible by 5, will be 5, 10, 15, 20, 25, 30 and so on. But here it is given even. We have to take even numbers. So 5 is odd, 15 odd, 25 odd. We will not write this. So what we will write? 10, 20, 30, 40 like that. So it's 10, 20, 30. Okay. And like that you can write many numbers. Next, x, where x belongs to n, means x is a natural number and x is less than minus 1. Do we have any natural number which is less than minus 1? No. Natural number starts from 1 only. So, it is null set. Remember? Null set. It means there is no element in the set. Next, determine which element of the set are natural numbers. Okay. Here, what element you can see natural number? Natural number starts from 1. So, there is no elements. Okay. There's no element which is natural number. Whole number starts from 0. So yes, 0 is whole number. What else? No. Now integers you can see minus 5 is integer. Minus root 3, no. Minus 1 by 2, no. 0, yes, 0 is integer. 2 by 5, pi, 13.4, nothing. So integers are only 2, minus 5 and 0. Now rational numbers. So minus 5 is rational number. We know that root 3 is irrational. So it will not come here. Now minus 1 by 2. Minus 1 by 2 is rational. 0 is rational. 2 by 5 is rational. Pi irrational. 13.4 is rational. 1 by 3 is rational. And 19 by 2 is rational. So these all numbers are rational numbers. Okay. Now, real number, all the numbers are real number, whether it is rational or irrational. So, all these numbers will come here. Okay, minus 5, minus root 3, minus 1 by 2, 0, 2 by 5, pi, 13.4, 1 by 3, 19 by 2. These all are rational numbers, real numbers. Okay, now next, write the following sets in roster form. Okay. So first, x is a 2-digit number and the sum of digit is 5. So sum of the digits should be 5. So what we can write? The number can be 14, 2-digit number, and 1 plus 4 is 5, or its reverse, 41. Or number can be 23, 2 plus 3, 5, or 32. Is it only 4? Can I write 50? 50 is a 2-digit number. And if I add 5 plus 0, it will be 5. So the roster form will be 41, 14, 23, 32, 50. Now next, x is an integer and mod of x is less than equals to 9. Now, what is this mod of x? Mod of x means numerical value of x. Numerical value of x. Numerical value, or you can say absolute value. It means the value irrespective of its sign. Okay. Now, here it is saying that mod of x is less than equal to 9 and it is integer. Okay. So here, if I write 9, yes, mod of 9 will be equal to 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 also. Can I write minus 1? So mod of minus 1 will be 1 only. So yes, I can write minus 1 also. So here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8 and minus 9. Right? So these all elements will come in this set. Now next, X is a letter of word suite. So in word suite, what are the letters? So here what we can write? We can write the set where S, W, E and T, because you know that we never write the repeated letters. So here the letters or roster form will be S, W, E, T only. Now next, X, where X is written in the form of n plus 1 upon n, where n is a natural number and n is less than 6. So natural number starts from 1. So if I take n equals to 1, what will come here? 1 plus 1, that is 2 by 1 or 3 by 2. We put here n equals to 2. Now n equals to 3, 3 plus 1, 4 by 3. Now n equals to 4, 5 by 4, n equals to 5, 6 by 5. Now here what question says? Question says that n is less than 6. It means we'll take n till 5 only. So these are the elements or roster form of this set. Now next, X is a composite number. So composite number starts from 4, 4, 6, 8, 9, 10, and so on. You can write it whole night, then also it will not over. So we can write only few and then you just put dot, dot, dot. Okay. Now next, write the following sets in set builder form. Okay. So in set builder form, we will write, yes. So 2, 4, 6, 8. So 2, 4, 6, 8, what we can write? We can write it as X. Okay. Where X is what? 2n. And n belongs to natural number. And it is dot, 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 dot. Means it is going till infinite. Can we write it in any other form? Yes. We can write it as any other form. How? Okay. So this first bit I'm writing here. So this can be written as X, where X is an even number. Okay. Where we can write X as even number. Right? So this one set can be written in two different forms. Now next, 3, 6, 9, 12, 15. So what we will write here? X such that X is the multiple of 3. Okay. So here X equals to 3n. Where n belongs to natural number and 3n. So maximum value is 15. So 3 5s are 15. N will be 5, max to max. So we will write n is less than 6. Or you can write it as X, where X is a multiple of 3 and less than 16. Now third, 1, 4, 9, 16. What you can say it? These are the square numbers. So we'll write it as x, where x is n square and n belongs to n. Now it is again dot dot dot. It means it is going till infinite. Now fourth one, 8, 9, 10, 11. So what it is? X, where x belongs to natural number and x is greater than 7. Okay, greater than 7 natural number is 8, 9, 10, 11, 12. It will go till infinite. Okay, now last 1, 2, 3, and 6. What are these? These are the factors of 6. Okay, x, where x is a factor of 6. Okay, now can two different sets have the same roster form? Yes, it can. Like if I write one set like this and another like this, so their roster form is same. What? This first one, 2, 4, 6, 8. So yes, it can have same roster form. So two different set can have same roster form. Now next, which of the following pair of sets are equal? If you remember, yesterday only we have discussed what are the equal set. If all the elements of one set is same as all the elements of other sets, then we can say that both the sets are equal set. Okay. Now here you can see D. Here we have D. Here E, we have E. C, yes, C. Now E repeated we never count. N, we have N and T, yes, T. So all the elements of this set are there in this one set. So these both sets are equal. Now next, second. Here A, B, B. Order doesn't matter, not at all. You have to just see all the elements of one set is there in the another one or not. Pi, root 2 and root 2. All the elements of this set is same as this one set. So yes, these are equal sets. Next, x is a zero of polynomial x square. What is the zeros of polynomial x square? It means what value should I put here of x so that this will become 0. So here only x equal to 0. Or you can write in this the set, the element will be 0 only. Now, x is the root of the equation x square equals to 0. So from here, if you find the value of x, you will get only 0. So you can see same element. So yes, it is equal. Now next, x has numerical value. Numerical value means value without sign. So x has numerical value less than or equal to 1. Okay. Now less than or equal to 1, you can take any value, like you can take -2, -1, 0 and up to so on. Now x is the root of equation this one. If you write its root, then what it will be? X square -1 equals to 0. So from here you can write x square equals to 1. And then if you solve it further, you will get x equals to root of 1, which is plus -1. So here in this, the elements are -1 and +1. So do we have in the same element in both the sets? No. So what we will write for this? Not equal. Okay. Now, yes, fifth bit. 5, 10, 15, 20. And 5, 10, 15, 20, and so on. And so on. So here you can see these 4 elements are here, but here we have some extra elements. So they are not equal. Okay, exactly same element should be there. Number of elements and the elements both should be same. Now next, 5. 5 means what? Null set. Null set means there is no element. And set with 5, it means there is one element which is 5. So these are two different things. One is null set means nothing is there. And second thing is the set where we have 0. It means nothing. That 5, we have that. So these two are not equal because here we have one set. This is called singleton, one element. This is called singleton set. Here, phi means no value, null set. So phi denotes null set. And here with one element, it is denoting singleton set. They are not equal. Okay. Now, next. State which of the following sets are finite and infinite. As I already told you, if you are able to count or if the number of elements are countable in a set, it is finite set. If not countable, it is infinite set. So x equals to z means x is integer and x minus 1 into x plus 2 into x plus 3 equals to 0. Yes, it is finite set because here what will come? Either if I put this equal to 0 means x equal to 1. If I put this equal to 0 means x equals to minus 2. If I put this equals to 0 means x equals to 3. So there are only 3 elements. So for these 3 number only it will become 0. Otherwise it will not become 0. So what it is? It is finite. Now next, x and 2 are co-prime. Co-prime means where the highest common factor should be 1 of 2 number. It can be composite prime or composite or prime, anything. So we can take, yes, 3, 2. We can take number 3 because the highest common factor or HCF of 3 and 2 is 1. HCF of 5 and 2 is 1. HCF of 7 and 2 is 1. HCF of 9 and 2 is 1. So there are many numbers where their HCF is 1. So they are co-prime. So this set is called infinite set because the number of elements are not countable. Now next, x. And what is x? X is a rational number between 3 and 4. So between 3 and 4, there are infinite number of numbers. So obviously it will be infinite. Now next, x is an integer and mod of x is greater than equals to 5. Mod means again absolute value without sign. So we have to write those integers whose positive values are greater than 5. Okay, so I can write it as 6. I can take 5 also. 5, 6, 7, 8. Like that, so many number. Can I take negative also? Yes, you can take negative also. Okay, so negative I can take as minus 5, minus 6, minus 7, minus 8. Like that, many numbers you can take. And basically, it is infinite set. Because here number of elements are not countable. So it is infinite set. Now next, okay. So in this exercise, we have only the 6 questions which we have discussed, right? So with this, our exercise 1.1 is completed. In the next video, we will be learning next topic. Okay, so I hope this is clear to you. Okay, so keep revising, keep practicing, and stay happy with maths. Bye-bye.